Our next talk for the day covers the subject of observability, and who better to discuss that than Carlos Gomez, Senior DevOps Engineer for the game-changing online investment management company Nutmeg. Carlos will explain when to choose between metrics, logs and tracing, and how to become proactive taking data-driven decisions.
Hi everyone, my name is Carlos. I used to be a developer, but I become DevOps Engineer because I'm very excited about containers and all this world of infrastructure as code. One of the most important or most exciting parts of the DevOps culture is this bit of observability. So I will be here today presenting a little bit what observability means for me. This is the agenda. You can take a quick look. Let's talk about distributed computing, what I call ephemeral systems. So nowadays, most of us are running our infrastructure on the cloud. You have different providers, but they are all basically kind of the same. You don't know where this hardware is. You don't have access to these machines anymore, like in the old days where you could just walk into a room and plug a keyboard and just try to debug your app, whatever is happening on that server. On top of that, all this cloud computing, it's very heterogeneous. You don't know exactly which kind of machine is underneath. You just know that they give you some kind of CPUs, amount of memory available, some disks, they give you some specs, some SLAs that will match. On top of that, you know exactly where these things are running. They have all the servers distributed geographically, meaning that the network is much more complicated than it used to be, where you knew that, oh, okay, this server is plugged into this one, then is the firewall, and then is this proxy here. Not anymore. We don't know what's behind the scenes. We don't know how many hops are over there. We don't know what's the latency within these different machines, where they are located. And so it makes things complicated and more unknown than they used to be. And on top of that, you might be using containers, which means that you might also be using some kind of orchestration on these containers, whether that is Kubernetes or OpenShift, Cloud Foundry, anything that can bring to mind. One of the main or the core concepts of containers is that they are volatile, they are reproducible, so you can spin up your containers and they will behave as the previous ones. The cost or the trade-off with this is that the schedulers are making the most of that, and they assume that you have that in mind when you design your apps or your infrastructure. So these schedulers might just, for one arbitrary reason, will just reschedule your containers somewhere else because they need to scale down a node or spin up, make more room for a much more important application, or basically you're running what it's called spot instances, where you pay a little bit bidding for the price of using that machine, and all of a sudden you don't want to pay anymore for that. You need to move everything away, which is basically like all times the machine has broken down, and then you have to move all the things somewhere else. Just things that happens. None of us is free for them to happen. Yet, if that's not even complicated enough, problems don't happen when you're working. They also happen during the weekends. They also happen while you are sleeping, while you're on holidays. But then, you cannot be all the time looking at your apps and inspecting them. Oh, are you going to fail? Are you going to fail? So yeah, all of a sudden they just disappear. There's nothing left other than what you have instrumented, what you have on this pillars of observability: metrics, logs, traces. So let's discuss a little bit more about this. So these pillars are trying to cover different scopes. You have logs, which is one of the most well-known observability instrumentations. Metrics is quite not new anymore, I would say. 10 years plus have been there. They give you another view of what's going on, much more technical details about what logging normally will give you, or maybe not as efficient as logging will give you. With metrics, you can do mathematical operations and aggregations that's quite difficult to do with logs. And tracing will give you much wider scope of in time what this request has has affected into your network. And there's a new pillar coming in quite recently called continuous profiling. I will have killed for this feature on my years of as developer. It's so cool. We basically try to profile your app all the time. So when you need it, it's there. So many times I've tried to debug a memory leak, then what hasn't been not being able to reproduce it myself, but only when users are using it, which is not perfect scenario. So will this kind of tool will give you all these insights after things have happened. So Google has released something for this recently, last year. This is a flame graph, inverted flame graph. Normally, flames goes up. Yeah, it will give you points in time, snapshot of the heap of your app at any point. So you can compare at this time, this was happening with the memory at this time, this sort of thing. So you can compare them and say, oh, this is the difference. This is where the memory is going to. And then easily spot problems, or at least potential problems. It's very cool. There are a few open source initiatives trying to produce this. One of them, I have a link at the end they talk about it. So I would recommend to watch it. OpenMetrics is the standard that is trying to bring together all the different definitions of metrics that have been happening over the years from different vendors. Try to put a little bit of put together all the effort of the community and trying to make the most of all these people, all these different either vendors or just open source contributors, put all that effort in the same place, in the same direction, and try to be do the most of it. In a similar way, open tracing, which has been there since the beginning, has been trying to lead, so to guide how to do traces on the cloud or distributed tracing. They recently joined OpenCensus, maybe not recently anymore, but they joined with OpenCensus to form OpenTelemetry. These two initiatives, these two standards, OpenTelemetry and OpenMetrics, are part of the CNCF, a Cloud Native Computing Foundation, part of the Linux Foundation. It's very cool. Take a look. There are a lot of projects referenced over there. Yeah, they're trying to bring this telemetry to some kind of standard. They overlap a little bit with OpenMetrics, but I think it's cool because they're all open source. And I think they will much more likely they will align somehow. So let's talk about logs. Logs is the most well-known of all these three pillars, four pillars now. We all know logs. We have been historically using logs to debug all the problems that have been happening with our apps, and it has been the only tool normally that we could use to debug it. This is nowadays how logging look like. This is called indexed logging. We collect the logs somewhere, forward them, someone pass them, create indexes based on the structure of those logs, and then you can search based on those indexes, those structures. This is, in this case, part of the ELK stack, Elasticsearch logs-Grafana, trying to find logs of the type HTTP where the HTTP code is 302. So those are indexes. These logs has to be parsed, and you can see on the left there are a bunch of other fields that you can search for. But there's a new trend. There's a new trend which is called index-free logging. Historically, we didn't have all these indexes, all this parsing available. We just have syslog or journald, then grep. And Loki is aiming actually to do the same. It's trying to become the cloud grep for logs, making things much easier to manage, to operate. One of the bad or the expensive bits of indexed logging is that it is quite hard to operate. If you ever had to manage ELK cluster, you might know what I mean. Indexed logging has a cost, has a price, which is computational power to be able to index, to process all these logs. You have to ingest them, you have to tear them apart, you have to process them, parse them, and create these logs, put them somewhere, and then reference with these indexes some entries over there. This has a cost in CPU, memory, which is basically money at the end of the day, and time, because things that are using heavily memory and CPU, they're hard to operate, basically. They're under a lot of memory and CPU pressure, and it makes it expensive. Grafana Loki means aims to get this as simple as this is one stream of text. I don't care what it is in there. You figure it out. It uses a little bit of indexes, but it aims to use the least of them to make it fast and reliable, and keep it simple. One of the coolest things of Loki is that it brings together, it puts together logs and metrics on Grafana. Grafana is a tool to dashboard or to display metrics, but it also displays logs, which is very cool. So now you can filter by this time frame, and you have the logs for your app plus all the metrics. It is so intuitive to do so. I mean, I don't know how we didn't thought about this years ago, because all the time I have my tab with logs, my tab with my metrics, so Grafana dashboards over there, and you have to try to make sure that the times that you're looking here are the same and they're correlated and they're all good. And this makes things so easier. They can have filters, they can do statistics, and they have a little bit more context, because observability is always about context. And all these different pillars try to bring more context to the developer and help her to try to put this world of the cloud into context, trying to find out problems that have happened, problems that are going to happen, and just to know how it's going on right now. Traces is, if you have to picture this as a mental map, it will be an interaction through the network with your systems, infrastructure, apps. Depending how much you instrument, you will get much more insights or not. So it should look kind of this. There is a network interaction, a call, that receives the service A, that creates a parent span. This is the first time I see this, or I know about this call. This is a new call into the system. So I'm going to create a parent span. And all the subsequent interactions with the network are going to be child spans of this one. And that gives context to all the future interactions of this call, or my system interacting with all the parts and knowing that the context of this interaction is this one. This has been initiated here. You can see the parent span on service A has multiple child spans. That means, or could mean, for example, interactions with databases, interactions or functions inside of the same service. This request hasn't lived yet this service, and then you see the logs. Logs are point in time, but you don't have context. You don't know what happened before, what happened after, where this log happened. And then you have another network call to another service, which is as well a child span of this parent span that originated on service A. And all of them are correlated. All of them are linked together. Doesn't mean when I say network call, I don't mean HTTP calls. This could be IMQP. This could be Kafka. So tracing is compatible with a bunch of protocols, including database protocols. So it could measure how long an interaction with the database took. And also, it's very, very cool because if you have some sort of queuing system, these interactions are spread through the queues. And if you have, for example, a batch process that runs every day or every week, month, when that batch process picks up those messages or that single message, which has that span, that trace on it, it will keep propagating the same span. It's very cool because after all the interactions with your network have occurred, you can go into your tracing system, query it, and you can see, oh, this happened at this point. And then at some point, some other interactions related to the first one happen as well. So it's putting everything into context and gives you much more insights of what a single interaction with the network originates or over your infrastructure systems. There are two main open source projects in this subject. I'm a quite big fan of open source, so I will be mentioning open source a lot. One is Jaeger from Uber. As you might have noticed, it's written in Golang. If you're familiar with Golang, that is a gopher. Gophers are the mascot of the Golang project. And the other one is Zipkin, which is the one I'm more familiar with. This is based on Spring Boot, or uses Spring Boot, and it's very, very well integrated with one of the libraries they use called Sleuth. And it will give you a lot of instrumentation for free quite quickly and easy to integrate. It's very, very cool. Both of them are doing basically the same thing, different approaches, different UIs. Talking about the UIs, this is Zipkin. You can see at the top, big span, which is the parent span originated by the mobile gateway, and then some interactions with the auth service and the content service. All of them, you can see them pending one from each other, parallel requests, another serial requests. With times, some span names, you can do annotations and add more context to them. Similar way, Jaeger does the same. This is basically the same representation of the same kind of data. Doesn't mean that Jaeger is different anyway. This is just basically a different trace, which is much more complex. Using an API gateway, using some parallel requests and other bits and bobs, but both of them are based on open tracing. So they both capture the same kind of data, and they will represent them in different ways. They both can also draw dependency graphs, which are very, very cool to know which services are talking to what. And depending on how much instrumentation, you will be able to spot errors or where all the requests are dying or things like that, depending how much and how smart you make your traces. Metrics. Metrics is one of the most exciting, at least for me. I really love metrics. Really nerd about metrics. This is Prometheus. This is one of the second, is actually the second project that joins the CNCF just after Kubernetes. So they are very, very good friends. They respect each other and they play very well together. So Prometheus is a system to collect metrics. Not only collect them, but they also have some functionality to create alerts based on those metrics. And then other systems for visualizing these metrics, like Grafana, can use them, consume these APIs, and then you can have much more nicer views of metrics. But Prometheus is very, very powerful, very nice to use, and I really, really recommend it. This is how a metric, well, actually, this is not a metric, this is a query for a metric, a PromQL language expression. The metric in itself is node CPU seconds total, and that's the name. Each metric will have a bunch of labels. Each label will have some values. And then on this example of the PromQL language, we are filtering this particular metric based on one of the labels and a specific value, and then wrapping this into a function because we're interested on the rate of this metric, which basically will give us the percentage or how much time are we using this CPU of this particular node. Dashboarding, also very cool, very, very nice. I really enjoy it. But this is also called the passive way of consuming metrics. This is part of monitoring. You will have to actively look into these dashboards to know what's going on. So you normally will use this to support some kind of investigation, or just basically to put it into a TV and see what's going on. They are very, very powerful. You can see different types of metrics, maps, different kind of tiles, green. Normally will give you in a very, very quick look the health of your app or your systems or your infrastructure. I really enjoy using them, and they're very, very powerful. And then we have the active approach for metrics, which are alerts. Alerting is the practice where you get some rules. You have some kind of systems. In this case, I use Prometheus. And with Prometheus, I evaluate rules, and consuming these metrics gives me a lot of power to use mathematical operations that Prometheus supports by on the core to make sure that I know what's the state of my systems. In this particular metric, this particular alert is very, very powerful because it has some graph links, have a runbook. It gives you a very detailed explanation of what's going on, at least in terms of pointing exactly what's going on. Maybe the description is not very specific, but alerts normally they aren't. That's why you have logs and traces and the other pillars. Each of them cover different things. And this one has a runbook. Runbooks are basically to actionate alerts. All the alerts should be actionable. You have an alert, you have to do something about it. Either fix it, either tweak it because it's too sensitive, or just remove it because it doesn't make any sense. Or it used to make sense, but not anymore. But yeah, do something about your alerts all the time. And then a special mention for customer data, which normally is stored quite far away from all this technical data, memory usage, CPU load, request latencies. But I think it's so important to have it all together, because when you have customer data and technical data all together, it gives you, again, context, which observability is all about context. You can have a very heavy loaded system, but if your users are experiencing your app perfectly fine, you shouldn't bother. At least you shouldn't panic. You can take your time, you can go for a coffee, and then fix your things, don't stress out. So yeah, it is very, very powerful. I'm not saying that you should only forward them to Prometheus or to the system, the metric system that you're using. But you can use these other external customer metrics systems like Google Analytics, Segment, Amplitude, and I don't know, others out there. You can use both. You can instrument your code to do both, and that will give you context, which is always about context. Talking about application performance management tools, I think it's very, very important because if they are out there, there are a bunch of companies doing this. The acronym for this is APMs, Sysdig, AppDynamics, Datadog, Instana, I think Google Cloud, AWS, I'm not sure they have, all of them have their own approach to this. These APMs will give you metrics, logs, and traces out of the box for free. You don't have to put any effort to instrument your apps or your infrastructure to do this. The counterpart is that you don't experience at least for me, the joy of instrumenting them and knowing what you're doing, and understanding these metrics and understanding these traces, logs. So important to understand them, because otherwise how you're going to use it. I have to say I'm a little bit reluctant of using them. Obviously there is a market for it, there is a niche for it. But because I'm quite open source driven, I have to mention Skywalking. Skywalking is the open source solution for this APMs. It's an Apache licensed APM. I use it on the past with not much success, but I have taken a look again, and it looks amazing. I used it quite a long time ago, and now looks so much better. It has some implementations with Prometheus, integrations with Prometheus, and integrations with Open Tracing, which is amazing. They just got up to date, and it looks really, really good, actually. That's all. That has been the presentation. All these are a bunch of references talking about some of the bits I've been talking about, links to most of the projects, I think are all of them. Books for free from Google, and you can read and download recently. I think they open it to be able to download them. Original thoughts from SRE engineers when they start designing SRE or defining what SRE means. A video from the KubeCon talking about this continuous profiling, which is really, really cool. That's it for me. Thank you very much, and I hope you enjoyed. Cheers.